Okay, welcome back to my own personal version of hell where I'm forced to do 9 different of these lessons in about 3 days, writing them, making worksheets, and recording them. So fun. I love it when they tell us stuff super late. But I guess it's a flexible situation, so you know what we do what we gotta do. So, alright. So this is logarithmic differentiation. So last time we looked at implicit and we looked at tangent lines. Okay? So this is more on the implicit side, but honestly, I think it's a little bit easier. There's not product rules or quotient rules or anything like that. There's really not too much that's tricky, okay? But if we look at this first example, so it says, what would you have to do to take the derivative of this function? Well, you would have to FOIL out this part and then maybe do the product rule inside of a chain rule, inside of a blah, 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 blah. Okay? It's possible, but it would suck. All right, so what we can do now that we've learned how to take the derivative of a natural log is use what's called logarithmic differentiation to break that up into pieces and get a nicer, neater answer for our derivative. Okay? So here's what we're going to do. We're going to start by taking the natural log of both sides. Okay? Okay, we're then going to expand the function out by using the properties of logarithms. Then we're going to find the derivative of each term. We're going to solve for dy dx, just like implicit. And then we are going to substitute y back in. Now, none of that makes sense right now, but it will in a second. Okay, just 3 examples today, and we're going to set ourselves off to have a pretty good weekend. I guess B-Day. It's Monday, so sucks. Anyway, so back to our very, very first example from the page. Okay, again, you could FOIL that out and then do product rule inside of a chain rule, but why? Okay, so here's what we're going to do instead. We're going to start every one of these things, and I'll always tell you that I want you to use logarithmic differentiation, and this is what that means, okay? We're going to start these things by taking the natural log of both sides. Maybe. Oh, that's fantastic. Okay, not really sure what happened, but there we go. All right. So we start by taking the natural log of both sides. All right, so now what we're going to do is we are going to say, all right, the natural log of y equals, and we're going to expand this logarithm out. So that square root is the same thing as a 1/2 power. So I'm going to bring that down in front. Okay. Then I'm going to split those things up with addition. Okay. Finally, I can do this. So really, that just becomes a that just becomes a 1. Okay. All right, so I've got it completely expanded out. So now what I'm going to do is I'm going to take the derivative of both sides. So I'll use a different color to show that. Maybe. Okay, I'm going to take the derivative of both sides. So the derivative of ln y is 1 over y dy dx. Okay, the derivative of ln x is 1 over x. This next derivative is 1/2 1 over x plus 1. And then 1/2 1 over x plus 2. Okay. Now I get 1 over those things because the derivative of x plus 1 is 1. The derivative of x plus 2 is 1 also. So that's why there's just 1s on top of those. Okay. So now I'm going to multiply both sides of my equation by y. Okay. Because that's going to let me solve for dy dx. And so my final answer, I have dy dx equals 1 over x plus, let's do that a little smaller, plus 1/2 times 1 over x plus 1 plus 1/2 1 over x plus 2. Okay, and then we're going to do times y. But instead of putting y at the back, I want everything in terms of x because that's how I started. We started out with it being explicit. I want to keep it that way. So instead what we're going to do is we are going to plug back in the original for y because that's what y was equal to. So it's square root of x squared times x plus 1 times x plus 2. Okay, there's our big, terrible answer. But it's really not too difficult. All you're doing is taking the natural log of both sides. You're using your properties of natural logs to split those up, taking a derivative, and then multiplying over your substituted back in y. Okay? So let's try it again. So again, our very first step is going to be to take the natural log of both sides. Okay? So that's going to let us say the ln of y is equal to, and we can split that up into the ln of x plus 1 plus the ln of x minus 2. Okay. Minus the ln of x minus 1 minus the ln of x plus 2. All right. So now I get to take my derivative. So I say 1 over y dy dx equals 1 over x plus 1 plus 1 over x minus 2 minus 1 over x minus 1 minus 1 over x plus 2. Okay, again, there's 1s on all the tops of those because the derivative of x plus 1 is 1, derivative of x minus 2 is 1, and so on down the line. Okay? All right, final step. Solve for dy dx. So we are going to say dy dx equals we're going to say, oh my goodness, I wish this pen would allow me to not detect my hand like a real Apple pencil, but of course they gave me this off-brand one that does not, so that's fun. Okay, so let's see. We're going to have 1 over x plus 1 plus 1 over x minus 2 minus 1 over x minus 1 minus 1 over x plus 2 all times that original function, which was x plus 1 times x minus 2 over x minus 1 times x plus 2. Okay. I would like for you all to pause this and go try that last one. And then turn it back on and let's do it together. All right. So again, we start all of these problems by taking the natural logarithm of both sides. So we have the natural log of y is equal to the natural log of x squared plus the natural log of the square root of 3x minus 2 minus the natural log of x plus 1 squared. All right, now let's bring down all our powers. So the natural log of y is equal to 2 natural log of x plus 1/2 natural log of 3x minus 2 minus 2 natural log of x plus 1. Okay, so once we've completely simplified, let's take our derivative. So we have 1 over y dy dx equals 2 times 1 over x plus 1/2 times, okay, put that 3x minus 2 on bottom, the derivative of it's 3, so put that on top, minus 2 times 1 over x plus 1. All right, final step is to multiply over that y and substitute it back in. So dy dx equals 2 over x plus 1/2 times 3 over 3x minus 2 minus 2 over x plus 1 all times x squared times the square root of 3x minus 2 over x plus 1 squared. Whew, there it is. Okay, again, these things are not terribly difficult. You just gotta take your time and you're gonna have a nice crappy answer, and that's okay.